Okay, I apologize again for sending you the homework. It was actually the old homework, so I sent it out. So we'll, that's what we'll do first, the homework that was
I
on.
sent you some this morning. I don't know if you
Yes,
received.
yes, I responded back to you, Alvin. Thank you.
Yes, Miss Barbara.
And you did good, but we have to go into scientific notation because you gave me amounts of money, which was correct for what I gave, but we'll go through how you should put that as a scientific notation. All right.
Okay, okay.
Okay, so we won't get to probability today because I want to go through simplification of radicals and also rationalization of radicals and the scientific notation. So I'm sure we won't get to probability today. So let me go to our homework. Okay, do you see the homework?
Yeah.
Yes, ma'am.
All right. All right. So let's look at the first one. Mercedes, which property is used for the first one? Say what it is and then tell me the property.
You want 15 to the third power on divide by 5 to the third power. That's what you want me to say.
That's right. Now what exponent property? And I gave the choices 1 through 5. Which one is it?
The answer should be number 2. Am I wrong?
More, let me ask Maureen. Is that correct, Maureen?
Excuse me.
I do number 5 for that.
And why is it not number 2, Maureen?
I don't know, Miss Barbara.
Alba, you had it correct. You had 5. Why isn't 2 correct, Alba?
Because it says 15 divided by 5, 15 to the third power, divide by 5 to the third power. So what I did, instead of division, I multiply.
No, it's division. My question to you, Alba, is why Mercedes said number 2 right here.
Yes.
And that's a division also, but why isn't number 2 correct?
Because it is saying the third to the 8th power.
No. The reason number 2 is not correct, Mercedes, notice the base is the same, right?
Yes.
But look here, this is a base 15 divided by a base 5.
Yes.
And that matches number 5, Mercedes, where you have X over Y, 2 different bases. You got it?
No.
Okay. X to the N over X to the M. That would have to be, if this was 15 to the third, let's just take this and copy it. And I want to copy this down here. Okay. Okay. Now I'm on the other side. Okay.
Yeah. Before we continue,
yes.
I wouldn't choose 5 because 2 is not bracket and 5 is bracket. So I'm looking at all notions.
No, let me show you why it's not. The bracket is not important here. Okay. You see, this is a 15, this is a 5. Now, if this were a 15, okay, if this was a 15, then your bases would be the same. Then it would be a number 2. You follow?
Oh, okay, because you have X at the top and X at the bottom for number 2.
That's right. The bases have to be the same in the division of exponents for it to match the division number 2.
Can you scroll up with the property a little bit? Let me see 5.
Okay. See number 5?
Yes, yes. I see number 5 and I looked at it first and I looked at 2. But just because it is bracket, I says, no, I'm doubtful. That's why I don't choose it because it's the first one I look at and it says it's bracket and 2 is not bracket. And what the proposition they give us is not bracket.
But
The reason
Mercedes,
why
what, look here, what is it equal
So
to?
I'm looking at all covering every notion that it has. That's why I don't choose it, because but I did look at it.
Okay,
As
so
a,
you have the parentheses here, but you don't have them here, but doesn't that look just like this? Yes, no?
yes,
Yes. See, when you take the parentheses out, it looks just like this.
yeah, but I'm not looking
15 to the third over 5 to the third.
I'm looking at how it begins, the first part of it.
No, you can't look at just how it begins, Mercedes. You have to look at the whole thing. That's why it has x to the y in parentheses raised to the n equal. You could just put the numerator to the power over the denominator to the power. And further, they broke it down into numbers here. 2 to the
Okay.
5th over 3 to the 5th, which is exactly like this.
Yeah, I did, as I said before, I did see what awful because of the bracket. I don't know if I should use it. So I just go to 2.
Okay, but the point is, Mercedes, you can't just look at the bracket. You have to look at the whole thing, the whole equality. You follow?
Yeah.
So doesn't this 2 to the 5th power over
Resemble.
3 to the 5th power look just like this?
Yes, it does.
Okay, that's why you pick 5. But the main reason you wouldn't is because you have 2 different bases. 2 has the same base. So if I had given you 15 to the third over 15 to the third, or 15 to the third over 15 to the 5th, any power, the base is the same, then it would have been a number 2.
Okay,
So mine is correct.
Point-
Robert.
Yes, yours was correct, Albert.
Okay.
And mine.
Yes,
So
Mercedes.
what you're saying is that forget about the bracket and look at how it is written.
No, you don't forget about the bracket. It's just that both forms are equal to each other. So when you have it in parentheses, you can break it down into the numerator raised to a power divided by the denominator raised to a power.
Okay.
You
Okay.
follow?
Yeah, thank you.
So this could have been written in parentheses, but then you'd break it down into numerator to the power 15 to the third over denominator to the power 5 to the third. Got
Yes,
it?
yes.
So you understand now why number 2 is not correct?
Yes.
You want to
Thank
tell me why? What did I just say?
You said the numerator and the denominator is not the same.
That's right. You must have the same base.
Yeah.
As
Remember,
the numerator.
that's right.
Yeah.
Base of numerator and base of denominator the same in division, then it matches property number 2. Got it?
Yes.
Any questions on any of the properties? Maureen, what is number 1? What property is that?
2.
What operation?
Can't see it, miss.
Right here.
2 x
Okay.
to the
Number
n
1, what operation, Maureen?
is x to the n. X to the m equals the x to the m plus m.
What operation?
Multiplication.
Multiplication. Maureen,
Okay.
this is multiplication. That dot there means multiply x to the n times x to the m, and then you add the powers. So for multiplication, you add the powers. You got it?
Yeah.
And notice with the numbers, you don't multiply them. You don't multiply 3 times 5. You add 3 and 5. 2 to the third times 2 to the 5th is 2 to the 3 plus 5 or 2 to the 8th. Alva, number 2, what operation?
Multiplication.
No.
Now, number 2.
Number 2 said x to the n over x to the m. What operation is that?
X to the n.
Divided by x to the m. So what?
That's a division.
That's right. That's a division.
Yes.
X to the n divided by x to the m is a division. And what do you do, Mercedes, when there's a division?
You're gonna flip to flip, change this sign to
No flipping, no flipping.
no flipping, just change the sign.
What do you do? No. When you're dividing exponents, what do you do with the powers?
You had them.
By the power
No.
Sidetrack.
Subtract,
track. Oh, sorry.
right?
I didn't
X-
get that one right, Miss Barbara.
X to the n over x to the m. Yeah, I noticed some of those. That's why I'm going through this, Alva.
Okay.
You subtract the power of the denominator from the power of the numerator. So x to the n over x to the m is x to the n minus m. And then when you have the numbers here, notice you same base, 3 to the 8th over 3 to the 2nd. And what's that equal to, Mercedes?
3 to the 6 power.
How did we get that?
We subtract the 2nd power from the 8th power.
That's right. Very good. Alva, do you follow that? You subtract the power of the denominator from the power of the numerator. So
Okay.
that's 2 from 8 is 6.
Okay.
Got it?
Yes. So I didn't get that one right.
Right. That's why I'm going through it, because I want to make sure you understand these properties. Okay, let me just copy this. Now, suppose I had, okay, let me make this a 5.
It's still at 1, Miss Barbara. We're doing the second
Well,
one.
we're still at 1. I'm going
Okay.
through
At
the
one.
rule. I'm going to the rules. So this
Okay.
is 5 to the 3rd divided by 2. And let's just make that, let me back up here and put a power on that. And make that a 2. Okay. Okay, Alva, this is a division, right?
Something
Uh,
black in my computer, so I just want to take it off.
Okay, now this is, okay, this is a 5. Can you see it?
No, I'm taking off the thing that black in the computer.
Oh, oh.
You want me to take it off now?
Can you see it? Can everybody see 5 to the 3rd
Yeah.
over 5 to the 2nd?
Yes, I can
Yeah.
see.
Okay, that's a division.
Yes.
Same base 5, right?
Hmm.
Subtract the exponent of the denominator from the exponent of the numerator. What do you get for this,
Yes,
Alva?
that's nice. I'm proud of you. Yes, Miss Barbara, I'm listening.
What do you get for this?
I'm not sure if she's seen it yet. She weren't seeing it.
Do you see it, Alva?
Yes, yes, Miss Barbara.
Okay, so what's the answer? 5 to the 3rd divided by 5 to the 2nd, Alva. What's the answer? Please put your phones on mute. Please put your phones on mute. Reminder, everybody's phone should be on mute or vibrate.
Yes, Miss Barbara, just a minute. It's
All right. All right.
yes, I turn it off.
Yeah, put it on mute or vibrate, okay?
Yes.
Now,
yes.
Alva, 5 to the 3rd divided by 5 to the 2nd. What's the answer?
5 to the 3rd divided by 5 to the 2nd.
Subtract the numerator,
Yeah.
the denominator power from the numerator power. So what would this be equal to?
the denominator power from the numerator.
Right, so what would that be equal to?
It would be 2/5, 2/3.
No, you're subtracting powers now.
Yes, it said subtracted the power, the numerator power.
From the denominator power. So what would be the
Yes.
answer?
So 3. Well, would it
3.
be
Go ahead, you're saying it. It would be what?
1?
Yeah, it'd be 5 to the 1 power.
Yes.
3 minus 2, right?
Yes, yes.
And that would be 5.
5 to the first 1 power.
That's right. 5
Yeah.
to the first power.
Yes.
Everybody okay with that?
Miss,
Everybody get that? Yes, Mercedes.
I just saw it, yes.
Question?
No, miss, I just saw it, I couldn't see, but I know I see it.
Okay, it's 5 to the 1 power.
Power.
All right. Subtract the denominator power, and that's a 2, from the numerator power, and that's a 3. 3 minus 2 is 1, and you could say 5 to the 1, or you could just say 5. Because remember, to the 1 power, just give you the base. All right. Same thing. All right, let's take another one. All right, let's take another one. Let me just copy that and change the numbers. Okay. Let me. Okay, now let me just copy that. I want to copy that and put, okay. All right, now let me take this. Suppose this is still 5 to the 3rd, and I'm dividing it by 5 to the 5th power. So what would that be equal to, Maureen?
5 to the second.
5 to the 1?
The second.
Mercedes, is that correct?
5 into 5 goes 1.
No,
And
subtract the powers. What do you get? Mercedes, is Maureen correct?
No, miss.
What should it be?
Beg your pardon, what did she say?
Say it again, Maureen. What did you say the answer was?
5 to the power 2.
She said 5 to the power of 2. Is that correct, Mercedes?
Yeah, she's correct.
Alva, is that correct?
Yes, Miss Barbara.
It's
5
not-
to the, no.
You say
she-
5 to the 2?
Yes.
That's not correct.
No, it's not. But she's
That's
subtract-
right. Is that Michelle? Michelle, what is it?
I know it's not that, but I'm not at the computer, Miss Barbara. I'm coming now.
Okay.
I'm gonna sit in class. 1 second.
All right. Michelle says not correct. So what is it, Michelle?
I know, I'm not sure, but I
Yes.
know that's not the right number.
Miss, unless it's 5 to the 15th power.
No, you don't
Is it?
multiply, you subtract. This would be 3 minus 5, right?
Uh-huh.
Yeah, then it is
Okay, Maureen, what's 3 minus 5?
it is correct.
Minus 2.
Minus 2. That's right. This should be a minus
Oh,
2.
let's see if you didn't put the sign.
Not, that's not the same thing, right, Mercedes?
Yeah.
I got the sign.
Okay, that's minus 2, or you could say what? 1 over 5 to the second. So if you got to use the positive, you've got to do the reciprocal. You got to flip it. So this would be 1 over 5. Just put this here. Okay, so then we can remember I say when you have a negative exponent, it's the flip of the positive. So this would be 1/5, and that would be to the second. Got it?
Yeah.
Yes, ma'am.
That's not the same as 5 to the second,
Okay.
because 5 to the second is 25. 5 times 5. 1/5 to the second is 1/25. Not the same thing, right?
Mm-hmm.
That's right.
Okay, so be sure, because I think you had one on your homework where it was when you subtract, you got a negative. Okay, any questions now when the signs? Yes, Alva.
We are still on the,
2, let me see.
that's.
No, that's 3, Mom.
No?
Okay, so we just
Hold
finished
on.
number 1, and then I gave you some examples there with division. All right.
Yes, yes.
All right, so let's go to number
2.
2.
Oh, 2.
I did get this one right.
All right, let's go to number
2.
That's not
see, where is number 2?
where your book.
Wait a minute, let me do a share again. Let me do a new share and bring that up again.
Can take off this.
No, that's fine. That's fine. No, I can't take it out. That's down there.
New share. I seem to have lost the homework here. Just a minute. Let me bring it up. See if I can bring it up again. Okay. All right, let me look at number 2. Number 2 was, let me just put it here because it looks like I lost it.
It was A to
Yeah,
0.
times a to the 8th. I have it here, but I
Yeah.
was trying to bring it up on the screen. I'll just put it. Let's see. Why did it bring it up on the screen? Like it dropped off, but okay, let me just bring it up on the screen.
Okay.
Okay, so number 2, let me put here number 2. Oh, there we go. All right, number 2, a to the 0 times a to the 8th. Maureen, what's the answer?
What did
I put A
Why?
because I multiply the A by the 0.
You multiply the 8 by the 0.
Uh,
No, this is a multiplication. You add.
add.
Any number to the 0, any number variable to the 0 power is what, mouse ladies?
1.
1.
Oh.
So what's 1 times a to the 8th, mouse ladies? You're on mute.
Sorry, I did say 1 anyway. I forgot that I
Yeah,
mute.
why did you say 1?
Because anything with 0 is 1.
Yeah, it's 1. So a to the 0 is 1. 1 times a to the 8th is a to the 8th.
Yeah.
But if you were going to add, you'd add the power of 0 and 8, Maureen, and you get a to the 8th. So you get, but this was put here to demonstrate that any variable or number to the 0 power is equal to 1. So this would really be 1. Let's put asterisk for multiplication times a to the 8th. So let's just copy that. And that's how you get number 1. Alva, I don't think you had that one correct.
No, Miss Lover, I didn't.
Oh,
So the answer is A.
yes, the answer is
But-
A.
But
Right
I do
here.
it. I do it wrong by getting the right answer.
No, you didn't do it wrong. You could
Oh.
add it, but I'm just saying this
Oh.
this was put here to demonstrate that rule when you have the
Oh.
power of 0, whether it's a variable or a number, is
Oh.
equal to 1. But what you did is okay. You add 8 and 0, and you get a to the 8th.
Okay,
Any questions?
yes, I have that one wrong.
Yes, but now you understand it, Alva?
Yes, Miss Barber.
Okay, any variable or number raised to the 0 power is
It's
equal to
1.
1.
Yes,
So this becomes 1 times a to the 8th is just a to the 8th.
yes, okay. So it's hay.
A is the answer.
Okay.
Okay. All right, Maureen, number 3. What's the answer?
Answer your number 3, Miss.
Okay, let me go to the let me put this all together so you see the choices.
I get A for that.
Yeah, that's what she said. You got it right.
No, I didn't say
I
she
thought
had
about
it
number,
right.
I thought
No,
about 5.
no.
She
I thought about
Maureen
the
did
other
not
one.
send me.
Oh, she didn't send you.
She didn't send me
You
answers.
got 2 right.
Mercedes, is 3 correct? Is Maureen correct?
With number 3 for A, I could say
She said, what was your answer, Maureen? A, B, C, or D?
Miss
A.
Barbara, before I answer you, can you blow it up a little, please? I'm using my phone is a bit small. I'm sorry.
Okay, no problem. Let me just make it bigger.
Yes, it's A.
You said A, Michelle?
Yeah, the reason why is, oh, never mind.
Go ahead and say.
Why-
Sam,
Why did you say A?
because, oh, yeah, it is A because, 5 into 5
Is 1.
is 1.
No, this is number
No,
3. She's
5
doing
into
2.
5 is
She's doing 2. Number
No,
2.
we on number 3.
Number 3. Number
Oh,
3.
you're on
Number
3
Then
now.
number 2. We're on number
and
3.
then you subtract 6 or maybe I should say 1 over 6. That's 1 time. So it's 5 in 5.
What is a 6 minus a minus 1, Mercedes?
5.
That's 5 to the 5th power.
No, 6.
Let
me write what I just said. What is 6 minus a minus 1, Mercedes? What's that equal to?
That is minus 7
No, plus 7.
plus
Because minus is plus. So that would be 7.
yes.
So what is the answer? For number 3, what is the answer, Mercedes?
B.
B.
Didn't I get that one right, Miss Barbara?
Oh, I
I think-
understand now.
You understand now?
Yes,
I
Miss
think you did have that one right.
Yes, I think I
I
have.
think you had that one right. Let me just check here.
Yes, I have it
Because I
right, Miss
recorded.
Barbara, because I have the answers them written down here.
Yeah, and I put them in the book when I went over it.
Yes.
So you had number 3. No, you had D.
Oh, D. Okay.
You had D for that one.
All right.
You put it as a reciprocal. No,
Oh, okay.
no,
So,
no. So this becomes, let me just write this here. Okay, that's 5, and you still subtract the exponents, right? So that would be 5 to the 6th minus a minus 1, right? So let's just put that in parentheses. Okay,
I had myself at
I'm
different
sorry,
ends.
5, not 6, 5. This should be 5. What was it, Maureen?
So I had myself wrong.
Oh,
But
but it's still subtracting, right? Subtract the
Yeah.
numerator, the denominator power from the numerator. So 6 minus a minus 1. Is that how you had it set up, Maureen?
No. I
Well,
had my,
what happened? How did you have it set up?
Sometimes mine come, but sometimes mine, like a lot of mine come in the phone, like where you know, something like you see that book part you got the
Right,
one.
right
You see,
here.
you see what you got D?
Yes.
Or that kind of like a bare one, right?
1/5 to the 6.
I didn't see that. I might think, oh, that was further down. That was long way further down, close to number 4.
Oh, you didn't see
Nah,
D choice.
nah.
Well, that's not the answer anyway.
I know though, yeah, but it's the answer. I
But you
know.
said A.
Yeah,
You just said 6 minus 1. You didn't take in
yeah.
consideration that the sign was a negative on the 1. You can't throw
But
away these signs.
uh,
If the rule says subtract the power of the denominator from the power of the numerator, you've got to use the exact power.
okay.
You can't just throw away the signs. So if you put it like this, 6, that's in the numerator, minus, that's the rule, minus 1 is the power. And remember, when you have a minus like this, it's
It's
like
a plus.
it's a plus. It's like you
Yes.
multiplying like signs. Minus
Yes.
times minus gives plus.
So it's a +1,
And a 6, and that
a
gives you the
7.
7. So your
Yes.
answer would be B.
Yes,
Right?
that's true. I pick D.
Answer
Yes,
B.
B. That's true.
Questions? Mercedes, you understand?
Yes, Miss. What I'm looking at, there was no sign at 6. 5 to the 6 power, there was no sign.
Yeah, but
But
there's a sign on the minus 1.
yeah, there was.
So, okay, so what's the problem?
Now I'm trying to see if the work is like this, and although there's no sign on the 6, you work it just as if.
But you follow the same rule
Okay.
in the
Okay.
properties, right? Same base, subtract the power of the denominator from the power of the numerator. That's what
Okay,
this
so Miss,
says.
so Miss,
Yes.
that means when we get something like this, like number 3, we look at the property that you gave us to find how to do it.
Well, what's the property for division? We just went over, right? The
Okay.
power of the numerator, and from it, we want to subtract the power of the denominator. That holds regardless of the signs on the power. That doesn't change.
Okay.
You got it?
Yes.
You're going to always subtract the power of the denominator. In this case, is a -1 from the power of the numerator. Okay? But
Yes.
remember, you've got to know your sign rules, and they don't change because they're exponents. Because remember, I told you exponents can be positive, negative, or 0.
Okay.
Right?
Yeah.
Questions on number 3?
No, what bothers me, I picked the wrong one, but I
Okay.
understand now because the 6 was negative,
No, the 6 is positive.
positive, and the 1 was negative.
That's right.
And if the 1 negative, you have to put a negative sign at the 6.
That
also.
you don't put a no, Albert, you don't put a sign on the 6. The 6 stays positive.
Yeah,
This is positive 6. Remember, when we don't put a sign, it's plus. But the exponent rule for division stays the same.
yes.
Take this 6, subtract the -1. So the minus there is for the rule right here, right?
Oh, okay.
The -1 here is for the sign on the power.
Okay,
You got it?
yes.
So if you always set it up like numerator power minus denominator power, you'll get it right. Just put in the numerator power minus for the rule, and then put the denominator power, whether it's plus or minus or 0. Just put that power there.
Yes, Miss. Miss, can you just scroll back to number 2? Let me just see something.
Okay.
Was,
Number 2, there we go, number 2.
the answer was what again? 5?
A.
Okay, A. Okay, thank you.
Mhm. The answer is A. And Maureen said 0 plus 8, and she got 8. That's okay. But
The
A
answer
to
for
the
number 1,
0 is any variable or number to the 0 power is 1. So 1 times A to the 8th just gives you A to the 8th. And that's A. Answer A.
and number 1 was 2, right?
Number 1 was 5.
That's 5.
What power? You
Oh.
had 2, but remember I told you that you had different bases here. So it can't be 1. 1 has to be the same base.
Okay.
See, 3 to the 8th over 3 to the 2nd. Whereas number 5, x over y represents 2 different bases. See, 2 to the 5th over 3 to the 5th.
Okay, thank you.
Got it? Okay, so that was number 3. And let's go to number 4.
Okay, I had sent text here and said I didn't really understand number 4 well.
Okay, that's another division, right?
Yeah, I'm sorry, miss. Can I say something if you continue? I
Yes.
did start to do some of these, then miss, I don't know, I said the devil is wicked. I have some answers and I want to send them to you, and then I couldn't find the thing to finish it. All I'm searching my website, I can't find it.
Sometimes they never get in your way.
Yeah, that's all I'm trying to finish it to send it to her before I fell asleep. I couldn't find it, and I fell asleep because I work all night.
But let me ask you now, this is still a division, right? And division says subtract the power from the power of the denominator from the power of the numerator, right? And even though this is a x value on the power of the numerator, Alva, to get a 5, the 2 must be subtracted from what number, Alva?
Is it from the numerator?
No, just I'm
Denominator?
asking you a power now. Okay,
Okay.
remember the rule. You subtract the power of the denominator from the power of the numerator.
Yes.
Now, if my denominator is a 2,
Yeah.
and I get a result of a 5 when I do my division,
Yes.
what must this x be that I subtract a 2 from it and get a 5? What must be the value of x?
So the value of x is 3? No.
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 What I'm asking you is this. Let me
Yes.
just write it here. Okay. Okay, what I'm asking you is this. Okay, you have a number, I'll call it n.
Yes, it could be x or n.
Okay, I said n.
Yes.
Well, let me call it x. That's what we have here. Now, x is some number, right? And that
Yes.
comes from x minus 2, that power is equal to 5. So what must x be?
X minus 2 equal 5. So x is 2.
No,
No, you say x
only
minus 2.
one number I can
The answer.
subtract to. I'm talking to Alva, please.
Beg your pardon.
Only I'm talking to Alva, please.
I beg
Only
pardon.
one number I can subtract 2 from and get a 5, Alva. What is that number?
Oh, okay, I understand you now, Miss.
Okay, so what is
Bauer.
x?
It's one number you can subtract 2 and get a 5.
Yes. So what is x?
X would be 1?
No.
No, x. Ah,
Let me ask you again, Alva. 2 subtracted from what number gives a 5?
3.
2 from 3 is a 1.
Yeah, 2 from 5 leave
No, I want to get 5 and I want to subtract 2. What must my number be that I subtract 2 from?
7.
7.
Oh, I understand.
You got me now?
Yes, Miss Barbara.
Okay. So
I'm way
so
off.
all right. No, sometime with the variables, it kind of
Yes.
throws you off, and I
Yes.
understand that. But what
Yes.
I'm asking is, there's only one number that I can
Yes.
subtract 2 from and get a 5, and that's a 7.
Yes.
Because 7 minus 2 equal 5.
Yes.
So go over to your division.
Okay.
I have a number here. I want to subtract 2 from it because that's my division rule. Yes. And get a 5. That number can only be 7.
Yes.
So the value of X here would be 7.
7. As simple as that.
That's it.
Simple. Oh
Any
my
questions from
goodness.
anybody?
You know what? The X always fool
That's
us up.
number 4 because it was bothering me. I couldn't figure
Yeah.
it out.
Well, yes. Go back to your division rule, right? Subtract
Yes.
the exponent of the denominator from the exponent of the numerator. So if I subtract 2 from some number and I get a 5, then the number can only be a 7. Because
Yes.
7 minus 2 is 5.
5. Okay.
Maureen, did you have that one correct?
Yeah.
Okay. Mercedes,
Yes, it's correct, miss.
you had it correct?
Yes, miss.
Okay. So that's how you figure it out. You want a 5 here, you have a 2 here, you subtract a 2 from some number, it can only be a 7 because 2 from 7 equals 5. Questions on number 4?
Okay, I figured it out now, Miss Barbara.
You got it?
Yes.
Yeah, you just plug in the value that you take 2 from and get a 5, and that can only be a 7. All right. Questions now, because you're going to see this again. You don't always have the numbers. You may have a variable, but if you know your rules, you can figure it out, even if it's a division or if it's a multiplication. Because multiplication, you add. So if you left out some values in your multiplication, you should be able to get that value, right? Okay. Now, since I said that, let me just take, let me just go over here and, okay. Now, let me do a multiplication. Okay, this is 4. I'll make it bigger in just a minute. Okay. 4 to the, let me put to the 3rd power. And let me just make that bigger. Okay, so I'm making this 4 to the 3rd power. All right, now I want to multiply that. Let me just put, okay, and I'll put asterisk. It's multiplication times 4 2, and let me just put that at X. And okay, and let me make that equal to, and you tell me what X is. This would be 4 to the 10th power. Okay, Alva, what is X?
X is 4 to the 4th power multiplied by 4.
To the X
The
power
X
is
power.
4 to the 10th. So what
Yes.
is X equal to?
X would equal to 13. 13, no.
What do you do when you multiply an exponents?
When you're multiplying an exponent, you had?
You add, right?
Yes, yes.
Okay, so
So 3
plus x is 10. What is x?
x is plus x is 10. 3 plus x is 10.
So what is x?
Hold on. 3 from 10 leave 7. X is 7.
That's right.
Yes.
Because you could only add 7 to 3 and get a 10. So
Yes.
x is 7,
10. Yes. X is 7.
right?
So yes, Miss Barbara. Yes.
Questions?
No, I'm understanding.
You understanding it now?
Yes.
Because the rule for when you multiplying
You have.
exponents to add the powers, right?
Yes.
So 3 added to what gives 10? That can only be 7.
Yes.
Questions?
No, thank you, miss.
Okay. So I want you to be able to get these values correct, whether they are numbers or whether they're variables.
So, miss,
Yes, Mercedes.
looking at the same work and take away the multiplication sign and put plus. Would it be subtraction?
No. If you put a plus, then you've got to actually do the 4 to the 3rd and then the 4 to the 10 and then get a number and then determine what the power would be to give the number. See, that would be a different problem.
Okay, great. Then
See,
we'll-
yeah, if you put a plus here, you'd have to say 4 times 4 times 4 and put
Oh,
a number.
all right, stop.
All
miss.
right, you got
Got
it? Yeah,
Yeah.
that would be a different kind of problem.
Yeah.
And then 4 to the 10, you get that value, and then you figure out what x has to be to give you that. So that would be a very different problem. You
Okay.
actually would not give you a problem with plus or minus with this. All right, because it would be several steps. Questions? Number 4.
No, thank you, miss.
Okay, we're at number 5. Number 5. Maureen, did you do number 5?
Yeah,
What did you get? What answer?
B.
That's what I-
Okay. Okay, how did you get? Tell me how you got B.
God,
That,
okay.
how did you? Okay, let me put this here. How did you factor this square root of 275?
I multiply 5 by 55, right?
what?
I get
Multiply.
5 by 55 and get 275. So then you say to simplify it, right? So
Yeah.
then I say 5 into 55 is 11, which be 5 square root 11.
Excuse me, miss, what was our answer?
She
I
said,
I think I have that one right to Miss Barbara. I have
what did you
C.
have?
C.
No, it's not C.
Let's see.
Okay.
It's B.
Answer is
Oh,
But Maureen, what were your factors? What were your factors of square root of?
5 and 55.
But neither one are perfect square roots.
that's right.
So I'm wondering how you got your answer. Because 5 doesn't have a perfect square root, neither does 55.
Because if you get B, should
No, B is correct, but Maureen
correct.
couldn't have gotten it from what she just told me.
that's what I'm saying. That's what I'm saying.
Maureen, you've got to break this into factors where one is a perfect square root. What
Yeah.
are those? What are those factors?
Okay, let's see.
What 2 square roots can you multiply and get square root of 275, and one is a perfect square root? Mercedes, you have them?
Yes, miss.
What goes here? Let me
We-
just put Okay, so you tell me what goes there, because you factoring this into two radicals, and one should have a perfect square root. So Mercedes, what did you have here for the first one?
I said 25,
You had one,
25,
25, okay. And what's the other one?
11.
11. Very good. That's your factors. And 25 has a perfect square root, a number multiplied by itself to give you 25. What is that number, Mercedes?
That the number multiplied by itself.
To give you
That's
25. So what's the square root of 25?
5.
Mercedes.
Yeah,
Square root of 25, Mercedes.
5.
5. And then, of course, square root of 11 cannot be factored into anything. It's a prime number, right? So we just put
5.
square root of 11.
Mhm.
And that's answer B.
Oh, okay, 5. I
Because
turn it,
25 into 275 is 11.
I turn
Yes.
it the other way.
Yeah, you turned it the other way, Alva. Remember when you factor these radicals, you factor them into two radicals.
Yes, I
And
turn it the other way, Miss
yeah,
Barbara.
but you got to pick one that has a perfect square root. And 25 has a perfect square root.
Yes.
Thank you, Mercedes. Very good. Now, Maureen, you made a guess because what you put in there could not be, you didn't have square roots. You said you put the 55 and the 5, but neither one of those have a perfect square root. So you couldn't have gotten 5 and 11 from those square root of 11. So you did actually a guess, right?
Miss, and I look at C, Miss, I says, where I laugh when I look at C, I say, oh my God, this is very tricky. Look at that.
11. I think yeah, see, but 11 is not the same as square root of 11, right, Mercedes?
Yeah, that's
Not
right.
the
You
same.
get a complete different answer.
Yep, completely different answer. Okay. All right, let's go. Any questions on number 5?
That is okay. I think I picked one of them, but it's the wrong one.
But remember, Alva, your first step is to break that radical into two radicals,
Yes.
but have one that's a perfect square. And I gave you a list of perfect squares, right? Did you get it, Alva? I sent it out some time ago.
Yes, you did.
You got so some of them you know already, right?
Yes, Miss Barbara.
Yeah, and others you may not know, but you can always refer to that list. All right, let's go to number 6. Simplify. And this is also breaking up the square root of well, the radical into two other radicals, right? So let's just say Alva, square root of 12. What two radicals can we put that?
Square root of 12.
Well, first of all, give me two factors of 12.
6.
Just the number 12. Okay. 12 equal, and you said it's equal to what, Alva?
6.
Okay.
And 2.
Okay. Those are factors, but neither one have a perfect square root. All right, so I give you another chance here. Give me two other factors. Two other numbers you can multiply and get 12.
Oh. 2 and 6.
You gave me 2 and 6. Same thing. 2 and 6, same as 6 and 2. So give me two other numbers you can multiply and get 12.
4.
4 and what?
4 and 3.
Very good, Alba. 4 and 3. Now,
Yes.
you would use the 4 and the 3, and the reason is that 4 has a perfect square root, right?
Yes.
So we can take the square root of 12, right? Let's just put it here. Okay, and we can make that square root of 4 times square root of 3. You gave me 4 and 3, right? So let's just put a 4 here and put a 3, right? So now we have this now into 2 radicals, right?
Yes.
Square root of 4 times square root of 3. Now, Alva, what's the square root of 4?
2.
2, right? So then this becomes 2, and let's put the square root of 3, and this would be 2 times square root of 3.
Yes.
What answer is that, Alva?
2 times square root of
A,
3.
B, C, or D? What answer?
That is B. The square root of,
No, 2
2.
times square root of 3.
Oh.
What's
2.
the answer? What's the
Oh,
choice?
three
What
is
choice matches 2 times square root of 3 of these choices? A, B, C, or D? Which one says 2 times square root of 3?
2 times square root of 3.
Is it A or B or C or D?
It's D.
D, very good, okay.
Yes.
It's
Yes.
D, because D
Yes.
is 2 times square root of 3.
Yes.
Sir
Questions on 6. You had that one right, Mercedes?
Smith.
What about you, Maureen? You had it
Yes,
right?
yes.
2 times square root of 3. Okay. All right, let's look at number 7. Mercedes, did you do number 7?
Number 7. No, miss, it beat me up, miss. Oh my God, I tried over and over.
Maureen, did you do it?
I couldn't break it.
I couldn't figure it out neither
I couldn't break it.
because
Oh,
I had the 40. At first, I was a put A, but then I said, can't be right. I couldn't figure it out. All
I
right.
just figured it out. I have to leave it.
okay. Let's do this. Let me put this 200. Now, 200, what 2 numbers can you multiply to get 200, Mercedes? One has a perfect square root.
Okay, to get 100, you say?
Yeah, to get, I'm sorry, 200.
Can that be 10 and 20?
I said one was a perfect square root, 10 or 20. Neither one has a perfect square root.
10, 10,
1,
10.
10 doesn't have a perfect square root.
Okay, it's 20 then.
20 does not have a perfect square root. You've got to give me
What?
2 numbers. Give me 2 numbers you can multiply and get one of them with a perfect square root.
Let's see. 20. No.
Maureen, you know them?
I
2 and
said
100.
102.
What is it? You
100.
were about to say it, Mercedes. What was it?
Okay.
I was at 102.
Yeah, 2 and 100, right? 2 times, and Maureen was saying the same thing, because 100 has a perfect square root, right?
Yes.
Okay, so you can factor 200 into 2 times 100. 100 has a perfect square root. That means you can factor the square root of 200 into square root of 2 and square root of 100, right?
Mhm. Yeah.
Okay, so let's do that. Let's just copy that. put the 100 and put the 2. So this square root of 200 becomes square root of 100, right? Times the square root of 2. So let me put the 2 here. Put this radical here. Square root of 2. Let's put that there. Okay. Now, what's the square root of 100, Mercedes?
Square root of 100 is 25.
No, what number times itself gives 100?
10.
10. That's right. So the square root of 100 is 10. So let's just copy this and put our 10 there. Square root of 100 is 10. So let's just put that there and put the square root of 100. Let's put our 10 here. And I put it in parentheses. All right. Okay. Now I have 40 times 10, and that's the coefficient of the square root of 2 plus the square root of 2, right? Okay, Mercedes, what's 40 times 10?
That would be 80.
Oh, please put your phones on mute. Please, please. 40 times 10 is what?
80.
40 times
Four-
10,
four-
Mercedes?
400. 400.
400, right? So that's 400,
That's what I
and
meant.
then square root of 2. Let's put our square root of 2 here, okay? And that's plus square root of 2. And what's that equal to, Maureen? 400 times square root of 2 plus square root of 2. What is that equal to, Maureen?
800 plus 2.
I'm sorry?
2 multiplied by 400 is 800, right?
No. I'm right here. 400 times square root of 2 plus square root of 2. What is that equal to?
440.
No. This is a coefficient of the square root of 2. And this is a 1 here. I'll put a 1 here. Right?
Mhm.
What is that equal to? Add the coefficients, Maureen. What do you get?
1, 3.
No, 3.
No. The coefficients are the numbers in front of the radicals. So you have a 400
2, good.
and you have a 1.
1.
Maureen, what's 400 plus 1?
401.
401. That's right. And then square root of 2. And what answer is that, Maureen?
Yeah, the same answer you had big raffle as it can be.
Yep.
But I didn't do it that long way though. I figured it out, but I did not do it out this long way.
Okay. How did you do it, Maureen? Tell me how you did it.
How I do it, I really do it before. I can't remember how I do it, but I know before I had it set different and everything. But I said then the honest number could be, because I know 4 or 5 did right in my mind. No, I know B, C, and D wasn't right in my mind.
So tell me, how did you get A?
I can't figure out Miss Barbara, but I guess it was A because I know it could be other numbers.
So you guessed the answer.
Yeah, but I didn't
Okay.
write it.
But I mean,
Yeah.
you didn't have a method of doing it. You say you just guessed it.
Yeah.
Okay.
Oh yeah.
All right. But there's a method of doing it. You can factor the radicals.
Mm.
Any questions on what we did here?
It's not so clear to me, miss.
Okay. So, all right, you have a radical 200, right? Square
Yeah.
root of 200. Now that factors into square root of 2 and square root of 100. 100 has a perfect square root of 10. So you take the radical, because the square root of 2, we leave it as is because that's a prime number. That does not factor into anything other than itself and 1, right?
Okay.
Okay, so we take our square root of 200, factor it, since we did 200 is 2 times 100 when we just factor the 200. That means the radical square root of 200 factors into square root of 100 times square root of 2 right here. Follow?
Okay, okay.
You see, I took
Yes.
the square root of 200 and broke it down between square root of 100 and square root of 2.
Yes,
These multiply to give me square root of 200.
yes.
Square root of 100 has a perfect square root, 10.
10.
There's the 10.
Yes.
Here,
Yes.
I still have my square root of 2. Then this is a multiplication. 40 times 10 is 400.
400.
Now, the numbers in front of the radicals, we call them coefficients. So you have a
Yes.
400 times square root of 2 plus 1 times square root of 2. And you can add these coefficients because they have the same radical, right? So
Yes.
400 plus 1 gives you 401, and that's times square root of 2, and that matches answer A.
Oh, okay.
So, Miss, you have to factor out the two pieces.
Yeah, well, you have to factor in your radical. See,
Yeah.
just like we took the number 200, we
Yeah.
factored it in a 2 and 100, right? So you can take the square root of 200 and factor it into square root of 100, square root of 2, right here.
Yes.
You follow?
Yes.
All right. Then the square root of 100, perfect square root, that's a 10. So we put the 10 here, still with the square root of 2, then multiply. 40 times 10 is 400. So now you have two coefficients all in front of square root of 2. And when that happens, you can just add the coefficients. 400 plus 1 is 401, and that's all times square root of 2.
Okay.
You follow?
Sort of, Miss. Better get it.
Yeah, of course.
It's Barbara. It's only so much the head can take at this age. But it's keep us going though.
But if you can factor a number, you can factor a radical,
He's excited, Miss, to do it, Miss.
Very
Right?
much.
right? Okay, let me just do this here.
I have my right answer, but I rub it out. I couldn't get no further than when I get to the 400
Yeah,
and the 400. Like when I get to the 40 and the 100, I know the square root of 100 but staying. So I say square root 2 plus 2, but I could get no further from there. But I said, so this is what I do. I said 2 from 2 is 1, but it was wrong.
but this square root of 200, you can just
I
think
know.
half of it. Half of it is 100, and 100
I
has
know,
a perfect square root, right?
I meant when I get down to the bottom here, like the 400 square root of 2 plus 2. I said 2 from 2 is 1, but I didn't know how to put a 1 there because that's the problem. So that way I get hooked number 1, but then I said it can be right.
Okay.
Yeah.
Well, just think up here, you've got to work with your square root of 200 because just like I said, the 2 is a prime number. So you just leave that alone. So work with the 200. Think of factors of 200. Well, just think if you divide that number in half, you get 100 and a 2, right? 200 divided by 2 is 100. So now you've got your factors 2 and 100 has a perfect square root. If I can break 200 into 2 times 100, I can break the square root of 200 and the square root of 100 times square root of 2.
I know.
Got it?
Yeah.
And then get the square root of 100, that's a 10. Square root of 2, do your multiplication. Now remember, coefficients, just like we say 6x, 6 is a coefficient. You can say 400 times square root of 2. 400 is a coefficient. So you can add the coefficients, right? 400 plus 1, 401. Is that making sense, Mercedes?
Oh,
Yeah, thank you.
that was my problem. So how you get the one when you say like 400 square root of
How
2
did I get
plus?
the 1? Well,
Yeah.
Maureen, remember the default is a 1, right?
Oh,
So square root of 2 without a coefficient, the default is a 1. I just put a 1 here just to make it clearer, all right? But but when you don't see a coefficient, it's a 1. That's the
oh,
default.
oh,
So I put the 1 here so you could actually see it. 400 plus 1 gives you 401.
oh,
Got it? Now,
Okay.
let me just do some factoring here. Now, Alva, what are 2 numbers you can multiply and get 60?
Ten and 6.
Okay, 10 times 6. Neither one is a perfect square root, right?
No.
So give me two more factors.
Oh, to get us a perfect square root?
Give me 2 other numbers you can multiply and get 60.
Oh,
10 and
okay.
6 are correct, but they don't have a perfect square root, right?
Okay.
So give me 2 other numbers you can multiply and get 60.
Hmm.
Maureen, how could she get the factors? We had a method we could get our factors. What would you put, Maureen, to get the factors
Okay.
of 60?
okay, let me see.
Square root of 4.
30.
Like if you can't see them, right? If you don't see it, you could put the 1 and you could put the last one 60, right? Okay, so
Well, you could get 2.
let's put 2, because 2 times 30 is 60. Neither one perfect square. So
You
let's
could
put a
get 4.
3. Let's put a 3. Let's just go in order, Albert. There's a method to this. You put a 3, right? 3
Mhm.
times what number gives 60, Alva?
What number give you 60?
3 times what number? What do you multiply by 3 to get 60?
20.
20, all right? Neither one perfect square. Let's go to 4. What number you multiply by 4 and get 60?
4.
4 times what number gives 60? Just say divide 60 by 4. What do you get?
60 by 4, you get 20.
No. 60 divided by 4?
4 into 3 times.
4
No.
times 3 is 12. 60 divided by 4, Alba.
Oh, wow.
That's mental math, actually.
2, 4, 16. I can't come up with that and say it, Miss Barbara.
60 divided by 4.
15.
I know
1/4.
4 is 16.
No, 15.
15.
I'm talking
four-
to Alva,
Beg your
please.
pardon.
I'm
pardon.
talking to Alva. 60 divided by 4, Alva.
15, Miss Barbara.
15. That's correct.
Yes.
Because 4 times 15
Is
is
60.
60. Okay.
Yes.
Now,
yes.
so we'll say 4 times 15, right?
Yes.
Now, I could also say factor of 60. So let me just get my radical over here. And you gave me the factors of 60, right? So let me just put 60 on the radical. Okay, now if 4 times 15 is 60, then I could say the square root of 60 is square root of 4 times square root of 15. All right,
Yes, yes.
so let me just put that there. Okay, so I'm factoring the square root of 60 into 4 times the square root of 15. So let's put 15. Alva, you with me?
Yes, Miss Barbara.
Right. Now, what's the square root of 4, Alva?
2.
2. So then I could just say 2. And then I can just put my square root of 15. That's it.
Oh, okay.
So the square root of 60 is 2 times the square root of 15.
15.
Now 15 can be factored into 5 and 3, but they both prime numbers. They both can't be factored in anything else. So you can just leave it. And if I said simplify square root of 60, you'd give me 2 times square root of 15.
Because you just take 4 miss and 4 times 15 is 60, right?
Yeah, Alva gave me the factors 4 times 15 is 60. So I could take square root of 15 and the factors or square root of 4 times square root of 15. And 4 has a perfect square root. So we put the 2 here and 2 times square root of 15. And that would be the simplification of square root of 60.
Yes.
Got it?
Okay.
Questions?
No, thank you.
No.
Miss.
Okay.
So that's all we should
Okay,
have worked
Miss
out.
Barbara.
Yes.
Okay, I see the scientific notation and I send it in words. Is that okay?
No,
If
you
I
sent
use-
it in as dollars. No, I really wanted it in scientific notation. Okay, we're going to look at that in just a minute, but I just want
All
to
right.
do another of factoring. Suppose you had, let's say, you take here, I want to take a different number. Okay. 72. Maureen, what are some factors of 72?
6. Okay. This is
6
72.
and what?
Well, not that for sure. Okay. 6 and 12 is 72, but 9 to them is not the way it's
Yeah,
called,
6
right?
and 12, they are factors, but neither one have a perfect square root.
Right.
Okay, so you want to give me another set?
36.
36
And
and
2.
and 2. Now, Alva, is 36 and 2 good factors of 72? If I wanted to factor
72.
72, okay, I want to factor the radical 72.
What about 18?
18 and what?
You say factor it, so we have 72.
Okay, this is 72. Now,
You have
Maureen
30.
gave me 36 and 2. I'm asking you, are those good factors that I can use as radicals?
Yes, Miss Barbara,
Why?
because 2 times 36 is 72.
Yes, but what makes it a good radical? Because remember, we want to factor this. She said 36 and 2. So that means square root of 72 would be square root of 36. And this would be square root of 2. All right. Now, what would that be equal to, Alva? What's the square root of 36?
72.
Square root of 36?
Oh, the square root of 36, it would be 18.
No, what number times itself gives 36?
Oh, 6.
6. So it'll be square root remember, square root is the number that
Number that
multiplied by
yes.
itself to get the number. So
Yes.
square root of 36 would be a 6, right?
Yes.
And then we just repeat our square root of 2. So if I said simplify square root of 72, this is what you would have. 6 times square root of 2.
2. Okay.
Got it?
Yes, Miss Barbara.
Most times they're given as a multiple choice, and you pick the 6 times the square root of 2. You leave the 6 because that factors in the 3 and 2 prime numbers, so they don't factor into anything other than themselves.
Self, yes.
Got it?
Yes, ma'am.
Okay, now we're going to look at scientific notation. And Alva, you weren't here when we went over that, but don't worry, Mercedes is going to help you out, right, Mercedes?
All right.
Right, Mercedes?
I give you in letters, Miss Barbara. I didn't know really what you're talking.
Okay.
Because you give us in numbers.
Okay.
So.
All right. So scientific notation. Okay. Mercedes, tell Alva what scientific notation is.
I'm not sure I can tell in words.
In words.
It's like moving the, oh, I don't remember the facts, the word. I'm sorry.
Maureen, you know in words what it is?
I can't remember, but I know it's moving the decimal
It
point
down because it's the first time.
to the
Sorry.
left.
Yeah, it's
And
just
some you got to move to the right.
it's just a shorthand way of representing numbers, and they particularly useful when you have small numbers and large numbers.
Okay.
Small numbers or large numbers. And what you do is, the first step is you create the number as a number less than 10. You multiply it by 10, and then you raise it to a power based on the direction you move the decimal point. All right, so let's do the first step, 105. We want to write that in scientific notation, right? Your decimal point is behind the 5. So we want to first write it as 1.05. So we're moving our decimal point from behind the 5 to between the 1 and the 0.
Oh.
Okay, because that number that we put times the 10, which is our base, it will be a number less than 10. So we don't want to put it between 10 and 5. That will create a number that's greater than 10. All right. Then the next step is to put times the base 10.
To the 1 power.
And then you raise it to a power based on the direction you move the decimal point. So if you moved it to the left, it's a positive power. If you move to the right, it's a negative power. So this is moved to the left. How many places, Mercedes?
1 place.
2 places.
Hold on. Did you hear me?
Yes, I heard you. How many places you said?
Wait a minute. 2
It's-
places.
It's 2 places. It's here.
2 places.
That would be 1, and here that would be 2. So we
2,
put a
yes.
2 here. Alva, you follow?
You move it 2 places
The
to
left.
the left.
And we
you
put the
say
power represent the number of places.
places that we,
moved.
okay. So the 10, what the 10 represent?
The 10 is the base 10 of our decimal system.
Oh, okay.
So it's always times the 10.
Okay.
So number less than 10 times 10, the base 10, raised to a power equal to the number of places you move the decimal point.
Which
If you
is
moved
2.
it to the left, it's
Mhm.
positive. If you move to the right, it's negative.
Okay.
Alva, you got
So-
it?
Yes, I kind of get it, Miss Barbara.
Okay,
So if
well,
you move it to the left,
positive
it's
power.
positive, and to the
To the right, a negative.
Move it.
So this 105 will be 1.05 times 10 to the second. And 10 to the second is equal to what, Maureen? What's 10 to the second?
100.
100. And 100 times 1.05 is 105. So you know that's correct, right? Now, Alva, I'll give you one here to try. Okay, suppose you had 3, 4, 6, 7. What would that be in scientific notation, Alba? Alba, are you there?
Yes, Miss Barbara.
3, 4, 6, 7. What would that be in scientific notation? Where's your decimal point and where would you move it?
Well, if you move it to the left, it's positive, it's negative.
No, it's positive. You're right.
Yes, positive,
okay.
yes.
Now your decimal point is behind the 7. Where would you move it?
The decimal point is behind the 7 now.
Yes. Where would you move this decimal point?
It's behind the 7. What would you want me to move it to, for a positive or a negative?
No. You move into the left, so you know it's going to be positive. But my question is, where would you move the decimal point? It's right here.
Okay, how many places you want me to move it?
No, you tell me. I'm asking you how many. Remember, it's got to be a number less than 10. So where should I move this decimal point?
To make it lesser than 10?
To get a number that I will put in front of my 10, and that number will be less than the number 10. So where would I put my decimal point? Between what 2 digits?
Between the 3 and 4?
Very good, Alva. Between the 3
Okay.
and 4. Because anything else would be greater than 10. Like if I put it
Yes.
here, it would be 34.67. So
Yes.
very good. So that would be 3.467. Now you put your times base 10. And how many places did you move it, Alva?
I move it 2
No.
1, 2, 3 places.
3 places. Very good, Alva. You got it.
Okay.
See how you got it?
Yes, but Miss Barbara, don't you can do it in words too?
In this situation. No.
If I had asked you, but if I said scientific notation, it has to be a number times base 10 raised to a power.
Okay,
All right.
Yes.
Scientific notation, that's the representation. A
Yes.
number less than 10 times 10 raised to a power representing the number of places you move the decimal point.
All
Okay.
right.
If you moved it to the left, positive power, move to the right, negative power.
So, Miss,
Okay.
Question?
yes, Miss.
Yes.
Say we get something like this for an exam, they won't indicate where to go. We have to look at the
Left
decimal
is
point
positive.
and figure it out.
No, they know these rules you have to know.
Okay, so as I look at
Okay.
it, what to do.
No, in a multiple choice, they might give you this a number and then they give you choices. And based on you knowing the rules, you select the right choice.
Okay,
Okay.
yes, thank you.
Now, this one, Alva. Okay. Our decimal point is here. Right here between the 0, 0. Now
Yeah.
we're going to move it so the number is less than 10. So what would I move? Where would I move my decimal point, Alva? It's right here.
To be less than 10.
To get a number in front of the times 10. So where would I move my decimal point?
Left or right?
Move it 2 places to the right,
Where would my decimal point go? Where would it go here?
between the 0 and the 3.
But then if it here, it's not, this is going to be 37.
Okay. So what you want it to go, Miss Barbara? I mean,
No,
you,
I'm asking you.
no, you say you want it to be moved. How many places?
No, you tell me, where would I put my decimal point so I have a number in front of the times 10 less than 10?
10. Figure out which number would less than 10. Then you know where to put the decimal.
But you can't have a decimal in front of the number. Like you wanted to put it here, that would be 0.37 times something.
So you'd
No,
have
you've
to
got to
move
have
it.
a number. Okay, so what would
1,
be the
2,
number?
3, 4. Well, you'd have to move it behind the 0.
No,
I don't know.
Maureen, where would you move it?
Between the 3 and the 7.
Between the 3 and the 7, Alva. 3.7
Okay,
times 10. How many places did you move it, Alva?
you move it 1, 2, 3 places.
3 places, right?
Yes.
I moved it to the right, so what would that decimal point be?
It would be 0.7.
No, I'm sorry, not decimal point. What would be the power?
Oh, the power would be raised to the third. 'Cause you
Plus
move
or
it.
minus?
A plus.
No,
A
minus.
minus, yes.
That's right,
Because you
minus.
move it, yes.
Yes, if I'm moving it to the right, it's going to be a minus.
Minus, yes. Move it to the
3.7.
left, it's a positive.
That's
Yes,
right. Okay.
yes.
Times 10 to the minus 3. And that's what it would be. All right.
Okay,
And 10 to the minus 3 is like 1 over 10 to the third. And that's like 1 over what? 1,000.
okay.
And 1 over 1,000 times 3.7 gives you 0.0037.
Can we get a little more of this? I like it. I'll work on it.
Okay. All right.
Yes.
Let's take another one like that. Okay.
You have
let's-
one left. You have another one left.
Yeah, I know, but I want to do another one with the less than 1. Okay. Suppose I had 0.0000654 Alva. What would that be equal to, Alva?
Okay.
Where would you move your decimal? Between what 2 digits?
You say zeros?
Okay, so what number goes in front of the times 10? Where would you move the decimal? It's right here, right? Where would I move? Between what 2 digits?
You'd move it between the 5 and the 4?
Then that's then that would be 65.4. That violates your, got to be less than 10.
Oh, okay.
That would be 65.4 if you put it here. And that would be greater than 10. So where would you move it?
You'd have to move it to the left.
No, you got to move it to the right, but between what 2 digits?
You put it between the zeros.
No.
0
No.
and 6?
No,
No, I don't know.
then you'd have a decimal. 6.54.
Okay.
Isn't that less than 10? 6.54.
Yes.
Okay, so you move your decimal point from this point to between 6 and 5. And then times 10, how many places did you move the decimal point?
6 and 5. You move it between 1.
No, you're right here.
Yes.
Now you're here. How many places is that?
1, 2, 3. 1, 2, 3, 4.
That's right, 4.
4
And would,
places.
yes, would it be positive or negative? 4 is correct, but it would be positive or negative.
It would be negative.
That's
Positive.
right.
Yeah,
No, you're
negative.
right.
Yes,
Negative. 'Cause
negative to the
to the
right.
right
Yes,
is negative.
yes,
All right. So
yes.
-4. Got it?
Yes, ma'am.
Questions? Now we have one more, Alba. And that one is the 765,000. This one. Tell me where you move the decimal point. Okay, let me put that here. Okay, now the decimal point is behind the 0. Where would I move the decimal point, Alba? Between what 2 digits?
Where you want it to go, left or right?
No, you are telling me, Alba. Alba likes to quiz me. I'm quizzing you, Alba.
Well, you're saying we have,
It's right
It-
here. I want to move it so that the number I put in front of the times 10 is less than 10. So where would I put my decimal point? Between what 2 digits?
to be less than 10.
Yes.
Well, I would say you move it to the 0, 0, to the right.
No, I'm moving to the left, but
Oh,
where would
you're-
it go? Where would the decimal point is right here, Alba. You don't see it,
Yes.
but let me just put it here. There's your decimal point. Now
Okay.
now I'm moving this decimal point to the left. Now where would it go?
Let's see.
Where would I put the decimal point?
You want to put it between the 6 and the 5?
Then you got 76.5. That violates my less than 10. 76.5 is greater than 10.
Yep.
Where would it go, Alba?
So put it behind the 7, Miss Barbara.
That's right, between the 7 and the 6. So that becomes
Yes.
7.65 times 10. And what's the power on the 10, Alba?
It would be 2 places.
Number of places you moved the
no.
decimal point. How many did you move it?
Okay, I move it 1, 2, 2 places.
No. You can just
1,
count here, Alba. Look, it's right here, right?
Yeah.
1, 2,
2,
3,
4,
4,
5
5.
places.
5.
Yes.
You just count the digits, right?
So
So
you have
this-
to put it the 5th to the 5th.
Yeah, to the 5th
Yes.
power. You can just
Yes.
count here. Once you put the 7.65, your decimal
Yes.
point is here. Just say 1, 2, 3, 4, 5.
Yes.
Just like up here, you said
So that's the
1,
10
2, 3, 4.
to the 10th
right here.
power.
No, to the 5th power.
Yeah, the 5th power.
10 to the
Yes.
5th power.
Yes.
All right.
Yes, Miss Barbara. So that's 7.
Okay. Any questions on scientific notation? Now, I want you to be able to do problems with scientific notation. Let me just do a new share here. Let's see if I can do a new share. And let's look at. Okay. Okay, now I want to, okay, so we went through scientific notation. Now I want to look at rationalizing radicals. Remember, what did I say rationalizing radicals was? Mercedes, you remember?
I'm not sure, Miss.
Maureen, you remember?
No.
Well, we're doing it to the denominator. We are changing the denominator from a radical to a number, to a rational number. In other words, think of it this way. We want to get rid of this radical in the denominator. That's all it is, okay? We're working with the denominator. So let's get rid of the radical in the denominator. And we reason we say rationalize because we change it from a radical to a rational number. And remember when we went through the number system, A rational number, a number that can be written as A over B.
Okay.
Okay.
What is one of the most common irrational numbers? Maureen, do you remember?
Irrational number. No.
Irrational.
Irrational.
Yeah,
No.
I gave you one. I said irrational. Then the number pi. 3.1416, et cetera, et cetera, et cetera.
Mm.
That's irrational because you can't write it as a fraction A over B. Okay.
No.
All right. So rational numbers, remember we had it some time ago. When we look at the number system, you can have rational numbers and irrational. So that's why it's called rationalizing, because we are changing the radical to a rational number. And do you remember how I said you do that? How do you do that, Mercedes? You remember?
To change the number one.
Yeah, to change, we want to get the square root of 12 in the denominator to just be a number. And I gave you a way to do that. What was that method? Remember? What do you multiply by?
2.
No, you
Divided by the-
multiply by the radical divided by the radical. In other words, we just take this expression here, okay. And we want, it's not number 2, take that out. And we want to multiply that by square root of 2 times the square root of 2. So let me just put
That's what I meant by 2, miss.
question.
That's what I meant by 2. When I say 2, you're going to multiply 2.
No, it's not 2, Mercedes. Remember, I went through that with you before. 2 is
Okay.
not the same as square root of. Okay,
Okay.
this has to be multiplied by square root of 12 over the square root of 12. In other words, the numerator by square root of 12 and the denominator by square root of 12. Okay, so this would be square root of 12. All right, and then multiply the denominator by square root of 12. So I'm putting this here because this is multiplication of numerator and denominator by the same. Okay, square root of 12. All right. So that's your first step. Multiply whatever that radical is in the denominator. Just multiply both numerator and denominator by that. All right. So let me just put that. Okay. Okay.
Okay, so you would say like.
Well, we're not finished yet now, but this
Okay.
is your first step, Alva. Whenever you're trying to rationalize your denominator,
Yes.
that means your denominator has a radical, right?
Yeah, yes.
You multiply both your numerator and your
And
denominator by that radical. And
Okay.
square root of 12 over square root of 12 is 1. So you
Yes.
really multiply by 1. And you know we can
Yes.
do that
Okay.
in math. We can multiply an expression by 1 and we're not changing the value, right? Got it?
Yes, Miss Barbara.
Okay, any questions on this first step?
So, okay, that's the first step.
Rationalize. Right.
Mercedes, you follow? Whatever that radical is in the denominator, that's what you want to multiply both the top
And bottom by.
expression and the bottom by.
Okay.
Okay, everybody okay?
Mhm.
Now, the next step is to actually do the multiplication. So the first one, this just becomes 2 times the square root of 12. Let's just put that here. That is 2 times the square root of 12. And I don't really need the, I'll just take that out, just put it as a coefficient. Now, square root of 12 times square root of 12. What did I say when you multiply a radical by itself? What do you get, Mercedes?
144.
No,
Multiply the two
a
numbers.
radical times itself gives you what? Maureen, you remember?
A 1.
No, it just gives you the number under the radical. Because this is really saying, remember when you say radical, you're raising it to the 1/2 power. And a 1/2 plus a 1/2 is a 1. So you just really just getting back the number that's on the radical.
Okay.
So a radical times itself just gives you the radicand, the number under the radical. Square root of 12 times square root of 12 just gives you 12.
Okay.
Square root of 6 times square root of 6 give you 6. Square root of 3 times square root of 3 just gives you 3.
Okay. Got the
You
radical.
got me?
Yes.
All right. Now, am I finished with this? Yes, no.
No.
Why?
Plus, I don't think you stop right there.
No, because it's not simplified yet, right? Why is it not simplified, Maureen? Maureen,
Because because of prime number.
no. Why is it not? Well, we've rationalized, we've gotten a 12 here in the denominator instead of the square root, right? But when you rationalize, you may have to do something else to simplify it, right? So you have to look at your numerator. Now look at square root of 12. Square root of 12 has factors. What are they, Mercedes? What are the factors of 12?
Okay. You have first it start with 1 and end with 12 out at the bottom. Out at the end.
Okay,
Then
well, give me 2 factors of 12. One is a perfect square root.
okay. 2 and I could say 3 or 4.
You mean 3
What?
and 4.
Mm-hmm.
Yeah, square root of 12 factors into 3 and 4, right? So let's just copy that. So this would be, okay, so this will be square root of 4. Let's put the 4 here. Times the square root of 3, right?
Yeah.
Excuse me, get some water. Okay, now this is all over 12. Well, let's put out 12 here. Okay. So you have, and I just put this all over. Okay. Now, what's the square root of 4, Mercedes?
2.
2. So this becomes then 2 times 2, and we just put our square root of 3. That stays. And we have then 12. Let's put all of that over, okay. And then we have 12 and here. Now, what is that equal to, Mercedes?
You made it 2 last part of it.
Yeah, I'm right here. Okay. Let me just take this out. I don't want this to be misleading. I don't need underline there. Okay. Now I have 2 times 2 times square root of 3 over 12. Is it simplified yet?
Uh, um, it could be simplified some more if they're still using the
Yeah, I
same.
can simplify it some more. You're right. I can. Tell me what to do, Mercedes. I'll put it here. Okay.
I can say 3 into 12 is
And that's, and then I put the 12. And what's 2 times 4, Mercedes?
2 times 4. 2 times 4 is 8.
I'm sorry, 2 times 2. I'm sorry. 2
4.
times 2 is 4. So
Okay.
that's 4. And then let's put the square root of 3 here. And then put this over 12. Put the 12 here. And is it simplified?
Can you go further still?
Yeah, what can I do, Mercedes? You're right. I can go further. What can I do?
I can say 3 into 12 or 4 into 12.
You mean 4 into 12, because I can't do the square root 3 with 12 because 1 is not a radical, right?
Yes.
So I can say 4 in the front, 4 in the 4 is 1 time,
Yes.
and 4 in the 12 is 3 times. So this becomes then what? Square root of 3 over,
1.
no, 4 in the 12 is 3 times. Square root of 3 over 3. So let's put square root of 3. And that would be over 3. And there we have it simplified.
Yeah.
Got it?
Yes.
Okay, so first step, trying to rationalize denominator. Multiply both numerator and denominator by that radical. There's your first step. Okay. 2 times square root of 12 just gives you 2 times square root of 12. Square root of a number times the square root of itself just gives you the number. So square root of 12 times square root of 12 just gives you 12. All right. Now, this is not simplified because the square root of 12 can be broken down into square root of 4 and square root of 3. Square root of 4 has a perfect square, so we put a 2. 2 times 2 times square root of 3 over 12. 2 times 2 is 4. 4 times the square root of 3 over 12, but 4 and 12 have factors that common factors, right? So 4 and the 12 is 3 times. Our answer is square root of 3 over 3. Any questions?
Square root of 4 goes 3 times. 3 equal 3. That's 3 over 3.
Abby, you have a question?
No, I was just looking at it, Miss Barbara.
Now, questions like
Barbara.
this, where they say rationalize these expressions.
Miss Barbara,
Yes.
excuse me, I get a call in from my workplace, but did you hear me on the line when I was talking?
No, I didn't hear you.
Oh, thank you. That's just what I want to make clear.
Okay. All right. So when you rationalize expressions, the point is you rationalize, but sometimes you have to simplify too. Okay. Sometimes it'll come out already simplified and you don't have to do that. But when it doesn't, then you have to do factoring to simplify it. That's the point I'm trying to make here. All right. So you may be given multiple choice, say rationalize these expressions, and they give you the choices. And square root of 3 over 3 would be one of the choices because that's the rationalization with this simplified form. Got it? Questions? Now I wanted to do some factoring, and also some simplification, but we're not going to have time to do that. But I really want to do, well, just a minute. I want to do, I think I have a, okay, we'll stop here because that's going to get too involved. Okay, so next time we'll do some simplification, some factoring. We're not going to leave this subject yet. And scientific notation, that would be part of your homework. and maybe one of the rationalizations, but not where you have to do the simplification. Maybe one of the ones where you just rationalize, where you really do this step and get your answer. You got it?
Mhm.
Okay.
And once you do that, then it would be in a simplified form. And then we'll get to
Oh.
some where you have to do rationalization and simplification.
So, Miss, this rationalization must come down to the simplest form.
Yes,
That's what
when
is here.
you rationalize, but you put your final answer in its simplest form. So sometimes it's not enough just to rationalize the denominator, because your numerator may need simplifying. Okay. So I want you to be able to see that. Like when you see like a square root of 12 in the numerator, you says, okay, that can be factored in as a 4 and a 3. A 4 has a perfect square root. Follow?
Okay.
So
Okay.
look for things like that where you have these numbers that can be factored into two other numbers. Got it?
Okay, Miss Barbara.
Okay. Now, scientific notation, Alvin, you know how you write the scientific notation, not the
Yes, ma'am.
dollars. And
Yes.
I didn't go to the reverse, but I'll
Okay.
go to reverse now. I went to where you took the number and went to scientific notation. Next time
Yes.
we'll take scientific notation and then go to the number.
Okay.
But I think you probably can do it. Maybe I'll just give you one just to see you try it. Where I
Okay.
give you the scientific notation, ask you to give me the number. Well, give you a multiple choice and you pick out the right number that matches the scientific notation. Okay.
Okay. All right, Miss Barbara.
Any questions on anything we've gone over?
Well, it was good. The
Yes.
class was
Okay.
good.
Yeah,
Yes.
we just got to do more practice. So I won't be giving you too much rationalization because I need you to do just a couple of more examples probably on that. But I will give you factoring and simplification. And the simplification actually involves the factoring.
Yes.
Okay. So you will have that on your homework. You'll have scientific notation, simplification, one rationalization, and factoring. All right. Those will
Okay,
be the
Miss Barbara.
problems on your next homework.
All right. All right.
Okay. So I will say so long to everybody.
Yes,
Okay.
have a good weekend.
Have a good weekend.
Yeah. And you did good
Yes.
today.
All right, Miss
You did
Barbara.
really
Thank
good
you.
today.
Weekend,
Okay.
everybody.
All
Okay.
right.
Okay. Seconds.
Okay.
Okay. All right,
All right.
Maureen, Mercedes.
Okay.
Okay.
All
Okay.
right.
All right. Bye bye,
Bye,
everybody.
everyone.
Bye,
Yes,
Okay.
Marie.
so long.
Okay.